Good day, everyone. My name is Tutor Dan, and I'm your tutor for today. Please do well to subscribe and follow us across all social media pages at Gordon School of Mathematics. In today's class, we'll be looking at the topic whole numbers and decimal numbers in standard form. Now, whole numbers are numbers without fraction. That is, they are a stand-alone number, while fractional numbers are numbers that are expressed in the form a over b, where a is the numerator, right? And then b is the denominator. So we say all numbers are numbers without fraction. Now, if all numbers are numbers without fraction, then what are fractional numbers? So fractional numbers are numbers that can be expressed in the form a over b. A and b here are variables that represents numbers or quantities, right? To say any number that can be written in a form that has a numerator and has a denominator is a fractional number. Now, fractional numbers can be expressed in form of decimal or ratio. For example, if we have 2:3, this is the same thing as 2 over 3, right? Where 2 is the numerator and then 3 is the denominator. So, numbers expressed in form of ratio are fractional numbers. Also, if we have 3.2, for example, is the same thing as 32 over 10. If you express or simplify this fraction, you will get 3. 10 through 32 is 3, right? Remember 2, add 0, right? Then you add points. 10 through 20 is 2. It's the same thing. So 3.2 is the same thing as 32 over 10, where 32 is the numerator, right? And then 10 is the denominator. So fractional numbers can either be expressed in form of ratio or can be expressed in form of decimal. Now, that goes to say that all numbers are numbers without fraction. That is, they don't have any decimal number attached to them, and they are also not expressed in form of ratio. So, examples of all numbers are, we have 1. If you look at 1, right, it is a whole number because it does not have any decimal point attached to it, and it is not in form of ratio. 0 is also a whole number, right? It has no decimal point attached to it. It is also not expressed in form of ratio, right? We have 32,000, for example. 32,000 is also a whole number. It has no decimal numbers attached to it, and is also not expressed in form of ratio. So any number that is without fraction, that is, it does not have any decimal numbers attached to it, neither is it expressed in form of ratio, is called a whole number. Whereas decimal numbers, on the other hand, are numbers with fraction. That is, they are fractional in nature. For example, we have 3.2 that we said. 3.2 is the same thing as 32 over what? 10. Right? You cannot express 32,000 as a fraction because it is a whole number. Whereas 3.2, that is a decimal number, it has a decimal point attached to it, is a fractional number. So all numbers are numbers without fraction, while fractional numbers are numbers that can be expressed in the form of a over b, where a is the numerator and b is the denominator. And then we said that fractional numbers can be expressed in form of ratio and can also be expressed in form of decimal. That is, all numbers are numbers that don't have any decimal number attached to them, just like we have 0.2. point 2 here is the decimal number attached to 3. And because point 2 is already attached to 3, we can no longer call 3 a whole number. So 3.2 then becomes a decimal number, which is also fractional in nature. Now, we want to write all numbers in standard form. We know that all numbers are numbers without fraction. Now, to write all numbers in standard form is to express that number in the form a times 10 raised to power n, right? Where a is a number between 1 and 10. Right? And then n is a positive whole number. Right? It means that n is a number that is not decimal, a number that is not fractional, right? So to write all numbers in standard form is to express that number in the form a times 10 raised to the power of n. A and n here are variables representing an unknown number or an unknown quantity, right? Recall that a variable in mathematics is a letter or a symbol that is representing an unknown number or an unknown variable. Now, to write all numbers in standard form is to write it in this expression, such that we can now make a known, we can now find a, we can now find n. And then we know that a is a number between 1 and 10. What does that mean? It means your a must be greater than 1, right? Between 1 and 10. Between 1 and 10, which means that numbers below 1 are not a member of a, right? And then numbers above 10 are not a member of a. So it means that a must be greater than 1 and a must be less than 10. That's what it means. It means that a must be greater than 1 and a must be less than 10. So it means that the value for a is between 1 and 10, right? So it means that to write all numbers in standard form, we must express that whole number in the form a times 10 raised to power n, where a is greater than 1 and a is less than 10, right? Then it means that we've written that whole number in standard form. In a situation where your a is 0.93, now because 0.93 is not up to 1, it means that it is not a number in standard form. And if we have 10.13, 10.13 is clearly above 10. So it is also not a. It is also clearly not a. So it means that we must write the number in this form, whereby our a is greater than 1, but less than 10. But less than 10. Examples. We're asked to express the following whole numbers in standard form. Of course, you look at the 3 numbers, you will agree with me that they are all whole numbers. 41,000 is a whole number. It has no decimal number attached to it. It is also not expressed in form of ratio. 3 million is also a whole number because it has no decimal number attached to it and it's also not expressed in form of ratio. 253,000 is also a whole number. It has no decimal number attached to it and it's also not expressed in form of ratio. Now, our aim is to write these whole numbers in the form a times 10 raised to power n. And of course, know that a must be less than 10 but greater than 1, where n is any positive whole number. Now, If I have 400, for example, right, the place of the decimal point for this number is after the last number, which is the same thing as 400.0. Now, if the decimal number attached to any whole number is zero, then the zero is inconsequential. It does not matter. It's the same thing as what? 400. But this makes us to know that the place of the decimal point for every whole number is after the last number, right? Now, if I decide to divide 400 by 10, this will give me 40. Now, I can also divide this number 400 by 10 by shifting the place of the decimal point backward one time, right? And this will give me 40.0. 0 is the whole number after the decimal point. It is inconsequential. It's the same thing as what? 40. Then, of course, which is the same thing as 40 times 10 raised to power 1. Because I shifted the place of the decimal point backward one time, right? 10 raised to power 1 is 10. 40 times 10 is what? 400. Is that so? It's the same thing. So, which means that 400 divided by 10 can also be done just by shifting the place of the decimal point backward one time. And that, if I shift it backward one time, it is the same thing as 40 times 10 raised to power 1, which means 400 can also be rewritten in this form, 40 times 10 raised to power 1. Now, what if I divide 400 by 100, right? This gives me 4. Since 100 is equal to 10 times 10, which is what? 10 raised to power 2. What does that mean? It means that I can also do this division by shifting the place of the decimal point backward 2 times. 1, 2. Right? This gives me 4.00. Now, because zeros are the numbers after the decimal point, they are inconsequential. Is the same thing as 4. Now, because I shifted the place of the decimal point backward 2 times, it's the same thing as 4 times 10 raised to power 2. The number of times I shifted the place of the decimal point backward. It's the same thing. 400 is the same thing as what? 4 times 10 raised to power 2. Right? 10 raised to power 2 is 100. 4 times 100 is 400. So 400 is the same thing as 400. Right? Now, what if I have 40,000 divided by 1,000, for example, right? This will give me 40, right? I can as well divide this by shifting the place of the decimal point. How many times? 1,000 is the same as 10 times 10 times 10, which is what? 10 raised to power 3. The number of zeros after 1, right? Which means all I need to do, I shift the place of the decimal point backward 3 times, right? And this gives me 40.000, right? Now, if I have 40.00, the number of zeros behind the decimal point does not matter. So it gives me 40. Now, it means that this 40,000 can be rewritten to say 40 times, how many times did I shift the decimal point backward? 3. That's 10 raised to power 3. Right? What does this mean? It simply means that if I'm to divide any number by the multiples of 10, all I just need to do is to shift the place of the decimal point backward the number of the multiples of 10. So if I'm to divide any number by 100, 100 is 10 raised to power 2. All I just need to do is to shift the place of the decimal point backward 2 times. So for example, if I have 3213 divided by 100, for example, to do this, all I just need to do is to shift the place of the decimal point backward 2 times, 1 and 2, and this gives me 32.13. Now, this can also be written as we have 3213 is the same thing as 32.13 times 10 raised to power. Since I shift the decimal place backward twice, we have 2 times. Right? Which is 32.13 times 10 raised to power 2. Now, how does this what does this have to do with writing our own numbers in standard form, which is in this form? Now, the difference between this and writing all numbers in standard form is that now, the difference between this division and writing all numbers in standard form is that we have to continue to divide the whole number by the multiples of 10 until we arrive at our A greater than 1 or less than 10. Now, if I'm to write 32.13, right, in standard form, this is not a correct standard form because our A, which is what 32.13, is clearly greater than 10. And our A must be what? Less than 10. So now, number one, to solve our questions, we have 41,000, right? We are to write or express 41,000 in standard form. Now, how do we express 41,000 in standard form? What we need to do is to keep dividing 41,000 by the multiples of 10 until we arrive at A to be less than 10 or greater than 1. Now, if I decide to divide 41,000 by 110, right? Which means I shift the place of the decimal point backward one time. This will give me 4100.0, right? Times 10 raised to power. I shifted it one time, so 10 raised to power 1, right? Of course, this 0 does not matter. It gives me 4100 times 10 raised to power 1. Is that so? However, my A, this has been written in form of A times 10 raised to power n. Our n at this point is equal to 1, right? Then A is 4,100. However, by the rule of writing in standard form, A must not be greater than 10. Must not be greater than 10. That is, A must be less than 10. Now, if you look at 4,100, 4,100 is clearly greater than 10. What do we then need to do? It simply means that we need to keep dividing until A is now less than 10. Now, if you shift it one time, we have 4,100. We shift it one more time, we have 410. It is still greater than 10. We shift it backward one more time, we have 41. 41 is still greater than 10. So you shift it backward one more time. We now have our A is now equal to 4.1, right? So 4.1 is now less than 10. So we are now good. So we now have 4.1, which will now equal 4.1 times 10 raised to power. How many times did we shift backward? 1, 2, 3, and 4. That's 4.1. 4.1000 times 10 raised to power 4. The zeros after a decimal point are inconsequential, so we have 4.1 times 10 raised to power 4. Now, to write 41,000 in standard form is to write it in this form, is to keep dividing 41,000 by 10 until we arrive at A less than 10, right? Which is this. So it simply means that 41,000, right? 1, 2, 3, 4. That gives us what? 4.1. All the zeros are inconsequential times 10 raised to power how many times you shifted backward, which is what? 4. Now, number 2, we have 3 million. This is the place of the decimal point, right? So what do we need to do? We need to begin to shift backward until we have arrived at A less than what? 10. Now, if we shift it one time, this is 300,000. It's clearly greater than 10. Shift it one more time, it is 30,000. It is greater than 10. Shift it one more time, we have 3,000. It is still greater than 10. If you shift it backward one more time, we have 300. It is still greater than 10. You shift it backward one more time, we have 30. It is still greater than 10. then we have to shift it backward again until we now have 3, which is now less than 10, but then it is greater than 1. So it means that to write 30,000 in standard form, we have 3.12345 1, 2, 3, 4, 5, 6 times 10 raised to power 6. However, the zeros after the decimal numbers are inconsequential. This is the same as 3 times 10 raised to power 6. And then number 3, we have 253,000. To write 253,000 in standard form is to divide 253,000 by 10 until I arrive at a less than 10. Now, if I divide one time, I shift backward one time, I have 225,300. It's still greater than 10. I shift one more time, I have 2,530. It is still greater than 10. If I shift one more time, if the decimal point shifts to this point, I will have 253. It is still greater than 10. So if I shift the decimal point to this place, I will have 25, which is still greater than 10. So I shift it one more time. I now have 2, which is what? Clearly less than 10, and it is greater than 1. So what do we have? This will give us 2.53000 times 10. How many times did we go? 1, 2, 3, 4, 5. We have 5. However, all the zeros that end at the end of a decimal number are inconsequential. This gives us 2.53 times 10 raised to power 5. And this is how to write all numbers in standard form. Now, writing decimal numbers in standard form. Of course, decimal numbers are fractional numbers. Now, to write decimal numbers in standard form, we also want to write it or express it in the form a times 10 raised to power minus n. Now, the difference between whole number and decimal number is that n for whole number is positive, but while n for decimal number is negative. Our a is still the same, is still a number between 1 and 10. Between 1 and 10. That is, a must be greater than 1, but less than 10. Right? Now, how do we achieve this? For example, express the following decimal numbers in standard form. Number 1, 0.000000132. Number 2, 0.0000725, and then number 3, 0.125. Right? Now, our aim is to express these decimal numbers in this form where a is greater than 1 but less than 10, and our n is what? A negative whole number. Now, unlike the whole number where the place of the decimal point moves backward, now to express decimal numbers in whole number, the place of the decimal point will move forward until we have a to be greater than 1 but less than 10. Right? So for number 1, we have 0.123453132. Right? This is the place of the decimal point. Now we need to keep moving the place of the decimal point forward until we achieve a to be what? Greater than 1 but less than 10. So if I move it forward to this point, I will still have 0.0. It is still not up to, I'll have 0, I'll have at this point, I'll now have 0, 0, 0.00. It is still not up to 1. It is still less than 1, right? If I move it one more time, I will have 0, 0, 0 points. It's still not up to 1. If I move it forward again, I will now have 4 zeros. It is still not up to 1. If I move it forward, I will have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, right? That's 5 zeros. If I move it forward, I will have 6 zeros. Still not up to 1, right? Then if I move it one more time, I will now have 1 point, right? 1 is now up to 1. Point there means it is now greater than 1, right? So we will now have 1.32, right? Now 1.32 is now clearly greater than 1, so it means that our A is now 0, 0. All the zeros before the first digit, right, are inconsequential. So our A is now 1.32, which is now clearly greater than 1, right? So this will now be written as 1.32 times 10 raised to power. How many times did we move forward? 1, 2, 3, 4, 5, and 6. Now, if the decimal point moves forward, then our n will be negative. N will be negative. If the decimal point moves backward, then n is what? Positive, right? So which means that if it moves forward, comma, n is negative. If it moves backward, then it means n is positive. That's just the difference, right? So since we move forward 6 times, our n will be -6, and this is our answer. For number 2, we have 0.000725, right? We need to move forward until we achieve a greater than 1. 1, 2, 3, 4. We now have 7.25. So this gives us 7.25 times 10 raised to power. How many times did we move? 1, 2, 3, 4. Since we moved forward, it's going to be -4. And for number 3, 0.125, we move it 1 time. We now have 1.25, right? Times 10 raised to power. We moved 1 time. It is -1. And that is our answer. Do these exercises and drop your answers in the comment section, and I'll be there to give you your mark whether you got it right or you get it wrong. Do these exercises and drop your answers in the comment section, and I'll be there to give you your mark whether you got it right or you got it wrong.